Welcome back, students. Today we're going to continue working with inequalities. However, this time, instead of just having one inequality with one variable, we're still going to have one inequality, but we're going to see two variables. So that means instead of having one number line when we graph, we have to put two number lines together, which is why you should be seeing coordinate planes. All right, so we have our x number line, we have our y number line, and together they make our coordinate plane. So before we begin, we're going to continue on with the topic that we've already covered, plugging in a number to see if it is a solution or not. So in this case, we're not just plugging in one number, but we're going to plug in two numbers because this is an ordered pair. So an ordered pair is always your x followed by your y. And so over here in our inequality, we are going to replace our x with a 1 minus 3. We're now going to replace our y with a 2. And we're going to ask ourselves, is this less than 4? So this is what we're trying to figure out. Is this less than 4? Is this true or is this false? So if you need to, you can feel free to use Desmos to evaluate the left-hand side, just typing this in. All right, but Desmos follows order of operations, which means it's going to leave the 1 alone. And then minus 3, a negative 3 times a positive 2 would give us a negative 6. This is really going to be 1 minus 6. So is that less than 4? So 1 minus 6 is negative 5, which is less than 4. That is a true statement. So what this means is that 1, 2, this ordered pair, is a solution to our inequality. It is far from being the only solution to this inequality, but 1, 2 is an example of a solution to this original inequality. So what are the other solutions going to be? Well, the way that you'd be able to find those is by graphing your solutions or graphing your inequality on a coordinate plane and finding a spot for where all of those solutions lie. So for example, let's do this one right here where we have y is less than or equal to negative 1/2 x plus 4. First thing that we're going to do is we are going to go ahead and graph this. This is what's called the boundary line. All right, so right here, this is our boundary line, and we're going to need to get this graphed. The way that we graph equations of lines, most common way is to use y equals mx plus b. So remember that m is your slope and b is the y-intercept. So if it's not already solved for y, please go ahead and solve your inequality for y. So in this case, it's solved for y. And so now I just need to compare this to y equals mx plus b. So notice that m is the number in front of x. So in this case, the number in front of x is negative 1/2. So that means that the slope of this line is negative 1/2. The y-intercept is what comes directly after x, which is a positive 4. So on the y-axis, okay, the slope m tells us how to move. The b, the y-intercept, tells you where to start. So on the y-axis, we would start at positive 4, and the slope tells us to move negative 1/2, which means down 1 to the right by 2. Down 1 to the right by 2. Down 1 to the right 2. Down 1 to the right 2, down 1 to the right 2. And if you're doing this on Alex, you only have to graph 2 points. But if you're ever doing something on paper, it's always good to make sure that you plot as many points as you can on the graph that has been provided. All right, so here is my boundary line. Something that's different between graphing an equation from an inequality is sometimes these points on the solution or these points on the boundary line are going to be solutions, and sometimes they're not going to be. If you ever have the less than or equal to or the greater than or equal to, it means that these points, if I plug them into the original inequality, so for example, 0, 4, so if I were to plug in 0, 4, which means that this makes it go to 0, which gives me positive 4, over here I'm replacing y with 4. 4 is less than or equal to 4 is a true statement, which means I need this to be included. If I was just working on one number line, I would use a closed circle to say that is a solution. But in this case, I'm working with two number lines on a coordinate plane. So if I ever have a less than or equal to or a greater than or equal to symbol, then that means I need to use a solid line. I'm going to include these points on the number line. If I have just a less than or a greater than symbol, that's when I'm going to be using a dashed line. So in this case, they should all be solutions. And that was terrible. Sorry, it's pretty hard to do this on the computer. But what this means is that these should all be included, and so that means that I want to make sure to use a solid line. So I'm going to cheat, and I'm going to let Cami make my solid line for me. There we go. The other thing is, these aren't the only solutions. So the numbers on the boundary line, these ordered pairs on the boundary line, aren't the only solution. The boundary line splits the coordinate plane into two halves. We need to figure out, is it the top half or the bottom half where our other solutions lie? So this is where we're going to use something called a test point. So with that test point, what we are going to do is pick any point that is not on the line. Okay, that's very important. Pick a point that's not on the line, but you get to pick any ordered pair that you want as long as it's not on the line. So pick any ordered pair that you want. I'm hovering right here at this point right here, so why not use it? All right, that ordered pair right there would be -3, +3. So this is my x and this is my y. All right, so what I'm going to do is I'm going to plug this in and see what I get. Do I get a true statement or do I get a false statement? Just like what I did up here. I want to see if this is a solution or if it's not a solution. So my original inequality is y is less than or equal to -1/2 x plus 4. So I'm going to replace my y with 3 is less than or equal to -1/2 times -3 plus 4. All right, so feel free to use Desmos for this. I don't think I have the capability of pulling up that screen with how I chose to record. All right, so I'm going to go through this how Desmos would by using order of operations. All right, so this is going to give me -1/2 times -3, which a negative times a negative is a positive. And then 1/2 times 3, what that's saying is what's 1/2 of 3, which would be 1.5. And then plus 4. So this is going to give me 3 is less than or equal to, and then 1.5 plus 4 would give me 5.5. So is 3 less than 5.5? Is that a true statement or not? Because I know they're not equal. So is 3 less than 5.5 true or false? That one is true. So because it's true, it means that this is a solution. If I picked another ordered pair, so let's say if I chose 0, 0 and plugged it in, I would have 0 is less than or equal to -1/2 times 0 plus 4. This would give me 0 is less than or equal to, this makes it 0, and then plus 4 is 4. 0 is less than 4, that's also true. So that means that this is another solution. I can keep picking any point that I want on this side of my boundary line, and I'm going to get a true statement. So to make it so then I include all of those as my solutions, I'm going to shade on the left, or on this case, it looks more like the bottom of this boundary line. All right, so this is saying the shading over here on this part of my graph is saying that all of these, any point, any ordered pair that is in this shaded region is a solution to the original inequality. Let's do another one. Okay, this next one is a little bit different, okay, because it just has x is greater than 4. So this means that it could be graphed on just one number line. But I don't have just one number line, I have two number lines. So what I need to do is remember that since I can't put this into terms of y equals mx plus b, it's one of those special cases, and only x is there, that means that this is going to only be guaranteed to go through the x-axis. So on the x-axis, I would find 4, and I'd plot a point at 4. And then this is saying x is equal to 4. This would be my boundary line. X is greater than 4. My boundary is at 4. All right, and only guaranteed to go through the x-axis, which makes this going to be a vertical line. Now, 4, if I plug this in, 4 is greater than 4 is not a solution, which means I need to use a dashed line. These boundary points on my boundary line are not included in my solution. So that means I need to use a dashed line to show, hey, these aren't really here. These really don't work. But on this side or on this side, one of the sides of this graph is where all of the solutions lie. So now we need to figure out what side of our boundary line do the solutions lie, and that's where that test point comes into play. So pick any ordered pair. It does not matter which one you choose as long as you don't choose one that is on the boundary line. All right, so for example, let's do 2, 2. So 2, 2, right there. So we have x, we have y. If I plug this into my inequality, x is greater than 4. It means I'm going to take the x term and plug it in for x. I get 2 is greater than 4. There isn't anywhere for me to put the y term. So that means I have this inequality right here. 2 is greater than 4. Is that true or false? Well, that's false. So here's where 2 is, which means I'm going to need to shade on the side opposite. Okay, so if that point was not a solution, it means nothing on that side of your boundary line is going to be a solution, which means that everything on the other side of the boundary line is going to be a solution. All right, for the next one, it looks like my formatting got a little messed up here. All right, this y is greater than or equal to 4x. That's going to be example 5. All right, so for this one, we have 2x plus y is less than 4. So we have 2x plus y is less than 4. I have both x and y, so that means I need to put it in terms of y equals mx plus b. So that means that 2x needs to go to the other side, so I'm going to minus 2x on both sides, and that will leave me with y is less than. I'm going to bump the 4 behind and slide my negative 2x in first because it's mx plus b, and then I have a positive 4, so then I have plus 4. All right, so y is all by itself. Now I can compare it to y equals mx plus b. The number in front of x is a negative 2, so if I write that as a fraction, that's negative 2 over 1. And then my b, my y-intercept, is at positive 4. So on my y-axis, I would plot a point at positive 4. My slope is negative 2, so I go down 2 to the right 1, down 2 to the right 1, and again, I'm going to continue to do so. Since I'm doing this by hand, I'm going to plot as many points as I can until I run out of room, and then I'm going to go the other way. So if I can't go down 2 to the right anymore, that means I can go up 2 to the left by 1. So up 2, left 1, up 2, left 1. All right, so before I just go ahead and connect all these points, I need to think about, are these points solutions? All right, so are they solutions? The easy way to tell is by looking at what inequality symbol are we using. Since it's just a less than symbol, it means that no, they are not included. So that means that we are going to have a dashed line. So how am I going to make a dashed line? Well, I'm just going to start making a line, just start making little line segments. There we go. All right, so where are the solutions? Because right now we don't have any solutions graphed on this coordinate plane. So where are the solutions? That's where the test point comes into play. So we need to come up with any point that is not on the line. Let's go ahead and use 0, 0. That's one of the most common test points to be used. And let's plug it into the inequality. So this tells me 2 times 0 plus 0 is less than 4. So 2 times 0 is 0, plus 0 is 0. 0 is less than 4. That is true. So that means that because 0, 0 is right here, it means that any other point that's on this same side as 0, 0 was compared to the boundary line is a solution. So we are going to shade on this side of the boundary line. All right, so 0, 0 is by far from the only solution that's possible for this inequality. Okay, pick any point from this shaded region and we will have a solution to the inequality. All right, for this next example, we have y is greater than or equal to 4x. This one kind of looks like you'd think that there would be just a vertical line or a horizontal line. However, we have y is greater than or equal to 4x, which when we compare this to y equals mx plus b, we actually have both variables. We have both the y and the x, which is telling us m, the number in front of x, is 4, which if I put that as a fraction is 4 over 1. It tells me how to move. The only thing that's missing is my b, my y-intercept. So what number really doesn't need to go there? Well, that's the number 0. All right, so when I plot this, when I make my line for this, I plot a point at 0 on the y-axis, but then I move up 4 to the right 1. So it does have a slope. It's not an undefined or a slope of 0, which means that this is not going to be a horizontal nor a vertical line. All right, so I'm just going to continue going up 4 to the right 1 or going the opposite way, which would be down 4 to the left 1, down 4 to the left 1. All right, now, when I connect these, before I just connect them, I need to make sure, is it going to be a solid line because they are included in the solution, or a dashed line? So because we have an or equal to, that means that this should be a solid line. Okay, I should be able to connect all these points with a solid line because they are included in my solution. Now, there's more to my solutions. This boundary line cuts my coordinate plane in half. Are they going to be over here, or are they going to be on this side of my boundary line? So that's where we're going to use a test point. All right, now I can't use 0, 0 like I did on the last one because 0, 0 is on my boundary line. So I have to pick any other point that I want that is not on my boundary line. So for example, let's go ahead and do 4, 4. All right, so 4, 4. So I'm going to replace y with 4 because here's my y value, here's my x value. I'm going to replace y with 4 and then is greater than or equal to 4, and then I replace x with 4 as well. So this is going to give me 4 is greater than or equal to 16. Is that true or false? So is 4 more than 6? That's false. So because 4, 4 is over here, it's not a solution. That means that any other point that's on this side of my boundary line is not a solution, which means that all of my solutions would be over here. All right, so in summary, what did we just do? Okay, what did we just do? Well, we said that in order to determine what type of a line we had, we looked at their inequality symbols. So looking at the inequality symbol tells you whether or not any point on that boundary line is a part of the solution. If you have just a less than or a greater than symbol, that's when you're going to use a dashed boundary line. So that's going to look something like this. Versus if it says or equal to, that's when you're going to use a solid boundary line because those points on the boundary line are a part of the solution. How are you going to determine where to shade? Well, your first step is to pick a point not on the line. It's very important that you don't pick a point on the line because we already know whether that point is a solution or not based on how we have the boundary line. If it's dashed, it's not a part of the solution. If it's solid, it is a part of the solution. So pick a point not on the line. And then what you're going to do is you're going to plug that point into the original inequality. And then you're going to determine, is that true or is it false? So if it's true, you're going to shade over the point. And if it's false, you're going to shade on the side opposite. And wherever you see this shading then is going to tell you where you have your possible solutions. So for example, going back up to these graphs, okay, this graph right up here, what would be a possible solution? Well, I can pick any point that's in my shaded region. So for example, this point right here would be a possible solution, which means that -5, -9 would be a possible solution. Points that wouldn't be a solution would be any point on this boundary line since it was dashed, as well as any point that's in the non-shaded region. So for example, 10, 0 is not in the shaded region, which means that 10, 0 is not a solution. Over here, possible solutions would be in the shaded region, but these would also be points on the boundary line. All right, so in this case, 0, 0 would have been a solution because if I plug it in, I would have gotten 0 is greater than or equal to 0. That's true. And the reason why I know that is because I'm working with a solid boundary line. So any point such as 0, 0 that is on the boundary line, when it's a solid boundary line, is a solution. Points that are not solutions would be anything that's in the non-shaded region, such as the ordered pair 10, -10. All right, I'm going to go ahead and do one more example, and this last example is going to be a word problem, a story problem. So this one says the girls' soccer team is selling hot dogs and sodas at concessions for a fundraiser to buy new soccer goals. Since they got the hot dogs and sodas donated to them, they get to keep all of the money that they made. They want to raise $2,000 to buy new goals. How many of each item must they sell if each hot dog costs $1 and each soda costs $1.25? All right, so first thing that you do whenever you are going through and you're working through a math word problem is read through it and then figure out, what am I ultimately trying to do? What am I trying to answer? And this answer, what I'm trying to do is figure out how many of each item they must sell in order to reach, their goal. So I need to figure out how much they have to sell. So my variables, I have two variables because there are two items that they are selling. And those two items are hot dogs and sodas. All right, so X is going to represent the number of hot dogs. I could have made that Y. It does not matter. I'm using X and Y because I'm knowing to graph it. So I want to have an X axis and a Y axis. Y is going to represent the number of sodas. Now what I need to do is come up with two inequalities. So relationship, how am I going to tie these numbers together? All right, so what I'm going to do is come up with an inequality here, but their goal is to try to raise $2,000. All right, so I'm going to go ahead and put 2,000 somewhere. So I'm going to go ahead and put down 2,000. They want to make at least $2,000, which means that whatever they are doing to make that money needs to be more than 2,000, or it could be exactly equal to 2,000. If this happens, if they get 2,000 exactly, or if they get 2,001, or if they get 5,000, okay, that means that they would be happy. They would have met their fundraising goal. Now, how are they going to make money? Well, they're selling hot dogs and soda, and they're going to earn $1 per every hot dog that they sell, plus $1.25 off of each soda that they sell. All right, so this represents how much money they're bringing in. They're not going to worry about tax, and since it said that they had the items donated to them, that means that they don't need to worry about any costs that they have to pay. Everything is just coming in as pure profit. All right, so 1x plus $1.25y needs to be greater than or equal to 2,000. So what we're going to do with this is we are going to get a graph that's going to represent our possible solutions. All right, so since we're going to be graphing when we have both x and y, that means that we need to put this in the form of y equals mx plus b. So first thing that we need to do to get y by itself is move this 1x over to the other side. So we're going to minus 1x on both sides, and that's going to leave us with $1.25 times y is greater than or equal to. I'm going to put the minus 1x first, and I'm going to bump the positive 2,000 to the end. Then y is not by itself yet. It's being multiplied by $1.25. So we are going to, all right, so since y is being multiplied, we are going to divide everything by 1.25. That is a positive number, which means that our inequality symbol stays the same. So we're going to have y is greater than or equal to. And then please use Desmos for a question like this. So negative 1 divided by 1.25, you can type that in, and it would tell you that it is negative 0.8. But then on Desmos right next to it, you can convert to a fraction. So please go ahead and convert that to a fraction. And that is the same fraction as negative 4 over 5. And then again, that still has an x with it. And then we'll take positive 2,000 divided by 1.25, and that's going to give us 1,600. All right, there we go. So this represents our boundary. Okay, this is going to give us our possible solutions, our first possible solutions for what they could sell in order to make their goal. And then we're going to figure out what if they exceed that goal, where those solutions lie. So we need to get this graphed over here. So first thing that we should do is figure out, well, since this is an application problem, that not every point on a coordinate plane would make sense. So first thing that we should do is we should go ahead and restrict this to the first quadrant. All right, what I mean by that is it's not possible to sell a negative number of hot dogs, nor is it possible to sell a negative number of sodas, which means that we only care about the first quadrant, which is where your values are positive for both x and for y. The second thing that we should do is notice that as I'm going, I just have 1, 2, 3, 4, 5, and so on. I know my first point that I need to plot is up at 1,600. So if I just go by ones, that's not going to work. So I'm going to need to change my scale. And so what I'm going to do is on both the x and on the y-axis is I'm going to go by 200s. So that means instead of going up 1, every time I go up by 1, I'm really going up 200. So this one's going up 200, this one would be going up 400. And I'm going to pause the video and I'm going to finish my labeling. All right, so what I did was I went ahead and labeled going up 200 every time and going over 200 every time. It's very important that since I'm going to be using slope in order to graph, that I keep my scale to be the same. So I went by 200 on both the x and on the y-axis. So now what I'm going to do is I'm going to identify that my slope is negative 4 over 5. That just tells me how to move, but my y-intercept tells me where I start. So on the y-axis, I would plot a point at 1,600, and then now my slope is down 4 and to the right 5. So down 1, 2, 3, 4 to the right 1, 2, 3, 4, 5. And then I'll do it again, down 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5. All right, because I'm using an or equal to symbol, that means that 0 and then 1,600, this ordered pair right here, would be a solution. This ordered pair right here, which is 1,000, 800, would be a solution, and so on. So what I need to do is I need to connect these with a solid line. All right, now these are not my only solutions. Okay, this is telling me my minimum values for what I would need to sell in order to get that goal of 2,000. Where are going to be the other ones? And so that's where you're going to use that, that's where you're going to use that test point. All right, so that's where you're going to determine, okay, which side of the boundary line are you going to shade? All right, so the test point, I'm going to go ahead and use 0, 0. I think that would be the easiest one. So if I plug in 0, 0 into my original inequality, that's going to give me 1 times 0 plus $1.25 times 0. Is that greater than or equal to 2,000? Is that true or false? So 0 plus 0 will give me 0. Is that greater than or equal to 2,000? Well, obviously that is false. So if I don't sell any hot dogs, if I don't sell any sodas, I'm not going to make that goal of 2,000. Okay, that's saying that any of these possible combinations down here is not going to get you to 2,000. Here at the boundary line is where you're going to start getting your goal. And if you go past it, that means that this region of the graph, then that means that you're going to get that goal of at least 2,000 as well. So what are possible solutions? Well, there are lots of possible solutions. Pick anything from this shaded region and you're going to get it. One of your minimum values would be if you sell 1,000 hot dogs and if you sell 800 sodas, right? Remember that your X represents your hot dogs and that Y represents the sodas. Okay, double check that. If I take 1,000 plus $1.25 times 800, that gives me 2,000 exactly. All right, so that is how we work with graphing inequalities in two variables. Okay, we graph them on the number line. Remember that if you ever are using a less than or a greater than symbol, that you're going to have a dashed boundary line. If you have a less than or equal to or a greater than or equal to symbol, you're going to use a solid boundary line. And then also do not forget to shade. Which side of the graph are you going to shade? Make sure that you use a test point in order to figure out which side holds your shading. And that's it.